Students, today let us learn a new theorem, and its name is basic proportionality theorem. It is an important theorem, basic proportionality theorem. The theorem is this: if a line parallel to a side of a triangle intersect the remaining side in two distinct points, then the line divides the sides in the same proportion. So, if a line parallel to a side of a triangle, this line L is parallel to this side BC of the triangle. Then what will happen? This line divide the other side. AB and AC are the other side. So, this line intersect the other side at two distinct points. P and Q are the two distinct points. Then the line divide the side in same proportion. This line divide these sides in same proportion. That means AP upon PB is equal to AQ upon QC. So we want to prove that AP upon PB is equal to AQ upon QC. So what are the given thing? In triangle ABC, line L parallel to line BC, and line L intersects side AB and side AC in points P and Q respectively. So next is to prove. What we want to prove? AP upon PB is equal to AQ upon QC. So for that we have to make a construction. Draw segment PC and segment BQ. Draw segment PC and segment BQ. That is the construction. See how to start the proof. At first we have to consider two triangles. One is triangle APQ and triangle PQB. Triangle APQ and PQB, AP is and PB, these are the two bases. APQ का base APA, PQB का base PB. दोनों बेस क्या है? कोलिनियर है. दोनों का बेस कोलिनियर है एंड दोनों का एक कॉमन वर्टेक्स है Q. APQ को Q is opposite vertex, BPQ को भी क्या रहेगा? Q is the opposite vertex. So if the bases are collinear and have a common opposite vertex, we know the height of these two triangles are equal. In triangle APQ and triangle PQB, what is the area? Ratio of the area? Area of triangle APQ upon area of triangle PQB is equal to AP upon PB. क्या रहेगा रीजन? Triangle with a equal height. This is statement number 1. Again, we have to consider triangle APQ and PQC. First triangle same है, APQ है, but second triangle क्या रहेगा? PQC रहेगा. APQ का बेस AQ है, PQC का बेस QC है. देखो AQ and QC क्या रहेगा? कोलिनियर, दोनों का कॉमन ऑपोजिट वर्टेक्स है P. सो दोनों ट्रायंगल का हाइट क्या रहेगा? हाइट्स आर इक्वल. Therefore, the ratio of triangle APQ upon PQC is equal to ratio of their bases. The same property, triangles having equal heights. This is statement number 2. So actually what we want to prove? We want to prove AP upon PB is equal to AQ upon QC. फर्स्ट स्टेटमेंट का राइट साइड देखो, AP अपॉन PB हमको बराबर मिला. सेकंड स्टेटमेंट का राइट साइड क्या है? AQ अपॉन QC बराबर मिला. सो राइट साइड इक्वल रहेगा तो ये क्या रहेगा? ये प्रूफ बराबर हो जाएगा. बट राइट साइड इक्वल होने के लिए क्या होना चाहिए? दोनों का लेफ्ट साइड इक्वल होना चाहिए. लेफ्ट साइड देखो, फर्स्ट वन का न्यूमरेटर एरिया ऑफ ट्रायंगल APQ, सेकंड वन का भी न्यूमरेटर क्या रहेगा? एरिया ऑफ ट्रायंगल APQ. फिर डिनोमिनेटर क्या रहेगा? एरिया ऑफ ट्रायंगल PQB. सेकंड में डिनोमिनेटर एरिया ऑफ ट्रायंगल PQC. सो न्यूमरेटर इक्वल है, सेम है, बट डिनोमिनेटर्स आर नॉट सेम. डिनोमिनेटर भी सेम रहेगा तो लेफ्ट साइड इक्वल हो जाते हैं, इसके लिए राइट साइड भी क्या हो जाएगा? इक्वल हो जाएगा. सो दोनों का डिनोमिनेटर देखो, वन इज ट्रायंगल एरिया ऑफ ट्रायंगल PQB and another one is area of triangle PQC. PQB is this triangle, PQC is this one. Actually, these two triangles lie between the parallel line L and BC. दोनों ट्रायंगल क्या रहेगा? पैरेलल लाइन का बीच में है ना बनाया, इसके लिए दोनों का हाइट क्या रहेगा? इक्वल रहेगा. और PQB का बेस PQ है, PQC का भी बेस क्या रहेगा? PQ है. इसके लिए दोनों का बेस भी क्या रहेगा? इक्वल. सो दोनों का बेस भी इक्वल है, दोनों का हाइट भी इक्वल है, इसके लिए दोनों का एरिया क्या हो जाएगा? एरियाज आर आल्सो इक्वल. एरिया ऑफ ट्रायंगल PQB इज इक्वल टू एरिया ऑफ ट्रायंगल PQC. क्या रहेगा प्रॉपर्टी? ट्रायंगल्स with equal base and height. This is statement number 3. So now the left sides are equal from 1, 2 and 3. Therefore the right sides are also equal. Therefore AP upon PB is equal to AQ upon QC from statement number 1, 2 and 3. Let us see another theorem, that is the property of an angle bisector of a triangle. Theorem is this: the bisector of an angle of a triangle divide the side opposite to the angle in the ratio of the remaining side. क्या समझ गया? The bisector of an angle of a triangle. ABC is the triangle and C is the bisector of angle C. So bisector of an angle of a triangle. It divides the side opposite to the angle. Which one is the side opposite to the angle? AB. So this bisector divide the side opposite to the angle. That is, it divide AB. कैसे divide कर रहे हैं? In the ratio of remaining side. AB is divided. So which are the remaining sides? AC and BC. So CE AB को डिवाइड किया कौन सा रेशियो में? AC and BC का रेशियो में. That is AE upon EB is equal to AC upon CB. That we want to prove. So to prove AE upon EB is equal to CA upon CB. AE upon EB is equal to CA upon CB. Construction is this. Draw a line parallel to CE through point B. So draw a line parallel to CE through point B. Extend AC so as to intersect at point D. So B से एक लाइन CE को पैरेलल ड्रॉ करने का, AC को एक्सटेंड करने का, दोनों D में इंटरसेक्ट हो जाएगा. So that is a construction. So what is the construction? Draw a line parallel to ray CE through point B. Next, extend the side AC or ray AC. Which intersect the line at point D. Okay, now we can start the proof. Ray CE parallel to BD and AD is the transversal. Ray CE parallel to ray BD and AD is their transversal. C parallel to BD and ray AD is the transversal. देखो AC and CDB क्या रहेगा? AC ये दोनों पैरेलल है. दिस इज द ट्रांसवर्सल. सो एंगल AC and angle CDB are corresponding angle. दोनों पैरेलल लाइन है. इसको ट्रांसवर्सल कट करेगा तो करस्पॉन्डिंग एंगल क्या रहेगा? कॉन्ग्रुएंट रहेगा. करस्पॉन्डिंग एंगल थ्योरम. Therefore angle AC congruent to angle CDB. This is one. The property is corresponding angles. Next, same parallel line CE parallel to BD on transversal BC. BC is the transversal. ये दोनों parallel है BC transversal रहेगा तो ECB and CBD both are alternate angle. Now ECB and CBD are alternate angle. So these alternate angles are congruent because these two lines are parallel. On transversal CB, angle ECB congruent to angle, so angle ECB congruent to angle CB. You can take it as 2, statement number 2. Reason is alternate angles. But we know that angle ACE congruent to angle ECB because CE is the bisector, that is given. ACE congruent to ECB. This is 3. Reason is given because C is the angle bisector. So क्या प्रूव किया अपन? पहले प्रूव किया these two angles are congruent. इसके बाद में प्रूव किया these two angles are congruent. given thing से मालूम है these two are congruent. इसके लिए क्या होते हैं? Therefore CBD, angle CBD congruent to angle CDB from 1, 2 and 3. Angle CBD congruent to angle CD. Therefore angle CBD congruent to angle CDB from 1, 2 and 3. So these two angles are congruent. वो प्रूव किया CBD congruent to angle CDB. That means triangle CBD is which type of triangle? Isosceles triangle. So we can use the isosceles triangle theorem. What is isosceles triangle theorem? Angle opposite to the congruent sides are congruent. But इधर क्या चाहिए हमको? इधर हमको चाहिए side opposite to the congruent angles are congruent by converse of isosceles triangle theorem. So which sides are congruent? CB, segment CB congruent to segment CD. Otherwise we can write as CB is equal to CD. Segment CD congruent to segment CB. Property क्या रहेगा? Side opposite to the congruent angle. That is CD is equal to CB. इसको statement 4 रखो. This is statement number 4. Now we'll take the bigger triangle, that is ABD. In triangle ABD, CE parallel to BD. That is by construction. Now, in triangle ABD, ray CE or ray EC parallel to ray BD. Now we have to apply basic proportionality theorem, because CE is parallel to one side of the triangle. In triangle ABD, ray CE parallel to side BD. So this is parallel to this side. What is basic proportionality theorem? Therefore, AC upon CD is equal to AE upon EB, or AE upon EB is equal to AC upon CD. Basic proportionality theorem, BPT. Actually, what we want to prove, AE upon EB is equal to AC, CA. AC upon CB चाहिए, but इधर क्या मिला? CD पे. But fourth में प्रूव करके रेखा, CD is equal to क्या रहेगा? CB. Therefore, we can write it as, therefore, AE upon EB is equal to AC upon, instead of CD we can write CB. Now it is proved. From 4.